I'm here to talk to you today about supply chain metadata, what it really means, what it is, how you can use it today. I've been mentioning attestations an awful lot throughout the keynote and earlier presentation. And I want to use this opportunity here today to kind of really go a little bit more in depth and show you what these things are, how you can produce them, and how we can start using them with Docker Scout. So I've divided the talk into like 3 sections. Talk a little bit about like where is this coming from, what is the supply chain. Second section is around like showing you a few examples. What are attestations, how do they look like? And then I'll do a demo at the very end. I want to leave plenty of time for Q&A as well. So I'll start with a little example here. I'm an engineer, I love coffee. I don't know, you guys probably do too. There's a whole supply chain involved here, and I want to use this analogy to drive home like what we mean by supply chain when we talk about software. There are an awful lot of ingredients that need to go into your coffee to make it really good. And there are these coffee beans down here, and someone is putting a fair trade stamp on them, right? So in a way, you can think about the coffee with water, beans, the coffee machine ending up in your cup is kind of like a supply chain. And someone has kind of put a stamp on like the beans. It's not, you're not going to go down there wherever the coffee is grown to kind of make sure that the coffee has actually been fairly traded. You're trusting that someone has made that like this assertion for you. And so there is a producer involved, and that supply chain down here at the bottom is something that you happily delegate to someone else to kind of make sure that that is actually fairly traded coffee, right? That's not you doing this. So in a way, this is a lot of like about trust here. And you can kind of move this over and kind of like apply the same principles to software building, right? The water becomes the build, the water becomes the source, the coffee maker becomes the build in the middle, package and so on. So this is your kind of process, and down there are dependencies that are ending up in your supply chain. And it's not like that you're going to go chase down each and every dependency, and it's transitive dependencies. So again, you're trusting that someone has done that job for you and kind of like asserts their security. But where's the risk coming in here? Like there are a lot of like places in the supply chain where things can go wrong. Like, is this dependency really coming from the publisher that you think it's coming from? Or has someone taken over a GitHub repository, for example, and kind of impersonated an artifact? Who is the producer? Is your build environment compromised? Has your kind of source code been tampered with? And so on and so forth. All of these things can really be attacked across the supply chain. So how do you make sure that this is all consistent and kind of falls in with what you expect? So how do we try to solve that problem? Well, there are a couple of things that we can do here. Firstly, we can document what's in your artifact, or what is in the artifacts that you consume ideally. So that's where the SBOM comes in, or software bill of materials. It's a little bit like the ingredients on your cereal box, right? It makes you understand what is supposed to be in that artifact that you're consuming, or that perhaps you're building yourself. Then provenance is all about where is a particular artifact coming from? How has it been built? By who? In what environment? When? How can I reproduce potentially that build? All of this is kind of captured in provenance. All the materials that went into your build, your base image, your build environment itself is being captured, hopefully inside that provenance attestation. And then lastly, it's all about establishing trust, right? It's not just enough that someone publishes these artifacts, these attestations with these artifacts. You also need to be in a situation where you can verify that these things are coming from like an authority that you can trust. And that's where signatures come in. And I want to talk a little bit about that as well. So signing attestations is really key for software supply chain security. Signing them and verification, that's really a key aspect. Once you have this data, once you have SBOMs, provenance, and ideally you have them signed, well, you have a bunch of data, but the question is what can you do with that data really? And that's where policy comes in. Policy, again, repeating what we said earlier in today's keynote, is about allowing you to create corporate standards of what you expect your, that's in this particular case, your artifacts to have. Are they signed? By whom are they signed? Where have they been built? Potentially on GitHub. Who has signed them? And so on. So that's kind of where policy comes in and where we can kind of start enforcing and evaluating policy. So in a way, I'm a cyclist, road cyclist. I live in Germany, and that's kind of the little map here. Following on with another analogy, policy is really all a little bit about like what, to me, when I cycle, my GPS is, right? Like there's an awful lot of data that I need to navigate while being out in the wild. And I could do that on my mobile phone while riding. But at the same time, I would get all sorts of notifications. I would get all sorts of like noise while I really want to focus on cycling. And I only want to navigate. So with policy, that's exactly what we're trying to do, right? Based on data, we want to help you just focus on what is really important to you. These attestations become input. We evaluate policies on top of that. And hopefully down the line, we drive remediation. And that's kind of really what we mean by like, get the data into Scout or into kind of your supply chain, and then start evaluating policy on top of that. This is a little sandwich diagram of like the three things that make Scout Scout. So we have trusted content at the bottom, and if you're a Docker user, you've probably used the Docker official image, and that's part of what we call trusted content. We have three trusted content programs: Docker official images, Docker verified publishers, and Docker sponsored open source. Without a secure base, you can't really have a secure software supply chain. So we, the Scout team, and Docker is heavily investing into that lower section of that sandwich diagram here by adding signed attestations to those trusted content images. Like let's take Node or Alpine, for example. Do expect in the due future to have attestations for these things so that you know this is authentically coming from Docker. We assert that a particular package is in that image. We assert that this image has been built on GitHub by this authority, by this workflow, against this Git commit char. So it really allows you to kind of make strong assertions on where these images are coming from. And then in the big background on top of that is what we call our system of record. So all the data that comes in, and in this particular case, for this talk relevant here is SBOM package data and provenance data and signatures. So all of that data is being stored and then allowing you as a user of Scout to kind of evaluate policies on top of that data. So things like, is my image signed? Or do I have all the required attestations attached to my images? Are things that Scout can help you kind of observe and hopefully remediate and improve in the future. All right, let's jump into building images with attestations. I don't know who has looked into this with BuildKit, but that's effectively all you need to do to start building provenance and SBOM attestations. There's an SBOM equals 1 parameter and a provenance equals 1, which are shorthands for like a longer parameter. Don't ask me why you need the 1. That is legacy in the Docker CLI. They don't do just flags. You always have to have a value as well. It's really weird. But again, this gives you SBOMs and provenance. It's not signed at that point, but it's very easy to get started. You can do this on any CI system. You can do this out of the box with GitHub Actions, with our build and push action. There's a little flag on there. You can just enable that, and you're good to go. What happens if you do that? Well, a couple of things. So this is an example, and I'm using the buildx image tools inspect command to look at the image manifest. So this is a lot of JSON here, but the thing that I want you to take away is when you previously build an image and push that into the registry, you are now building an OCI index that firstly references an image up here. So this is your stock standard Docker image or container image. And there's a new image down here with an unknown architecture that is effectively referencing the original image up here by digest. And that's the attestation. So it has been attached to your image. It's part of the OCI index. And therefore, it kind of is backwards compatible with all the OCI registries. And we will be looking at supporting reference types when they become available in the future. So a new part of the OCI spec will have reference types so that you can have an external artifact being attached to something else. Given that is not widespread, it hasn't been released as a final version yet, and it's not available in all registries. BuildKit is producing kind of these OCI indexes, which work across all registries at this point. Let's dig in a little bit deeper. So let's take a look at this attestation image. So this is what you get when you're looking at one of those attestation images. You get two layers. So normally when you look at a Docker image, you get a layer per Docker layer, and that's your binary content. It's a tarball of your file system, right? Overlay file system. In this particular case, it's not an image. It's one layer per attestation. And which attestation this is kind of dedicated by this predicate type. So you can see this is an SPDX document, which is one of the standard formats for SBOMs. So in this case, that layer represents an SBOM. And this layer down here, the SLSA provenance, is of course a provenance attestation. Let's drill into one of these attestation layers. So I can, again, drill into that. And now I see that this is really an in toto statement. An in toto statement is a way to bind a subject. What do you want to address to a particular predicate? In this case, we are effectively addressing two tags, and you can see this down here. This is latest, and there is like a different tag, a commit char here. So these are the subjects that I want to attest some content to, and down here I have just removed everything. This is where the SBOM would go. So this is where your standard SPDX document would go, for example. And so this at that point gives you an OCI index with an attestation image with provenance and SBOM attestations. If you're building multi-arch images, of course, this is just going to grow. So you'll have one image for like AMD 64, and then you have an attestation image, and then you can have an ARM 64 and an attestation image. So they always go in pairs. And you can copy them around, right? They move, like when you pull these images, they're getting pulled down. When you copy them into your own on-prem registry, they're available there as well. Now, something really interesting has been pretty silently announced during today's keynote, but Docker is finally starting to sign these attestations. And we're going to be using a technology called OpenPubkey. And that technology has been pioneered by a company called Bastion Zero, whom we are partnering. And what's really interesting for developers, hopefully in this audience, is that this is a zero configuration signing solution. So the goal of this exercise is that at the end of the day, if you're using GitHub Actions to build your Docker images, or an environment where another OIDC provider is available, which is on Amazon you can get that, on Google you can get that, you don't have to do anything, and those attestations will just start to be signed by the fact that you're running that on GitHub, for example, by the fact that you're running this on Google's Cloud Build, for example. And so we announced the partnership with Bastion Zero today. We also announced an initiative in the Linux Foundation. So we donated the whole source code into the Linux Foundation. So start looking into this. This is the GitHub repo and the GitHub organization where all this code lives. And what we did announce is not a final product. This is a start of a journey in which we want to involve the community, because this is going to be a lot of work to get kind of trust established. You need security researchers to validate the proposal, and so on and so forth. But I want to take the opportunity to show you what's going to change when you start using OpenPubkey with, for example, BuildKit. Remember previously we had an in toto statement that was having a subject and a predicate. Now we are switching that, replacing that statement with an envelope, part of the in toto spec, and that has a payload, which again is your in toto statement, base 64 encoded, And then in the signatures array, you'll find an OIDC OpenPubkey signature. And that signature will, and I'll show you this in a minute, you can do a lot of assertions. Like, it's more than just verifying that a thing has been signed by a certain identity. This is coming out of GitHub Actions, so there's a lot more in there. So for example, we can verify tags. We can verify which was like the name of the GitHub Action workflow that was produced this. Is that what you expected? We can verify, and this is the repo own ID here. GitHub keeps a unique ID per every organization. So even if you delete your org, no one else can name squat that org. So it's a very safe assertion to say, this is the Docker org. I know exactly that this is coming from Docker at this point. And GitHub is standing in here and making sure that, OK, this can be trusted. The provenance attestation contains the Git char, as mentioned earlier. And the signed OIDC contains the same information. So we can compare if these two things actually match. So did the thing that is in my image, was that actually the thing that GitHub cloned for us, right? So that making sure that there is a tight connection here and the thing isn't dirty is really important, and it allows you to do a lot of like strong assertions on this. The thing I want to highlight here, a lot of signing solutions currently around container signing, and they make verifications somewhat of an opt-in, right? So you can always bypass. So you end up with a signed image, signed attestations, but you're not really kind of, I wouldn't say forced, but opting in is not a very strong security posture, right? You want to make sure that your developers, every time they do a Docker pull, a Docker run, and you in your organization decide to say, OK, I need these images to be signed by Docker. I need the provenance shard to match. I know that this is the workflow that these are supposed to be coming from. We are going to make that part of like these Docker CLI operations. And we're going to start shipping policies with the CLI. Of course, you can override that. That will at least verify these DOI images, Docker official images, so that you can't end up with something that isn't authentically Docker. And that's the same for when you type Docker run, and of course Docker pull, I mentioned that. And there are other like runtime integrations that we're exploring as well. Another piece of metadata that can as well be signed, but I think it's worth kind of like mentioning in this is the whole notion of if you're a producer of software and there's a vulnerability scanner coming in and telling your consumers that, hey, your container is vulnerable to something or your image is vulnerable to something, you might want to also say, you know what, I'm actually not affected because X, I have mitigation in the container, this is not executed at runtime. Or you want to say, yes, I am affected, and that's what you need to do. You need to upgrade to the next version of my image where I fix this. And that's where the vulnerability exploitation exchange specification comes in. It's one of the things that CISA is standardizing around what they expect like government providers to ship and so on. So it's similar to what they're doing with SBOMs, a new specification. I think it's really important to know that VEX, when you hear that, doesn't stand for vulnerability exclusions. It can also mean that a producer of a piece of software wants to tell you, I am affected. So it's really a way of communicating what is the status of a particular CVE, a particular vulnerability for a particular product. And the other thing to keep in mind here is that you don't have to trust that statement, right? Like it's, again, it can be signed, it should be signed, and it should ultimately be up to the consumer to say, well, I trust Docker that they have VEX statements for Docker official images saying that this is not exploitable. I trust, I don't know, Microsoft that this is not exploitable for the Windows containers and so on. But I do not trust random guy on Docker Hub saying that that is not exploitable, right? So there is a level of trust here, again, with signatures. These things being signed, we can start enforcing that. And that is a very basic VEX document here. You can see there's a bit of metadata here, who's the author. And then we get down into the statements. There can be multiple statements in there. I do realize the green is not very easy to read, but hopefully I can go through this in a little bit more detail in a second. The CVE ID here, and then within a particular Docker image, I want to make a particular NPM package not vulnerable. I want to say not affected, and then when I say not affected, I have to specify a justification. There's no way around it, otherwise it wouldn't be a valid VEX statement. And in this case, I just say inline mitigation already exists. So this is already fixed in the container. All right. Let's try that stuff and see if it works. Let's go into the demo. Let me just bring up the source code here real quick. This is this very simple application, a node application. It uses Alpine. It uses a pinned digest to make it vulnerable, like to kind of step back in time when I run a Docker build to catch an image with vulnerabilities. So let's do this quickly and run a Docker build here. So I want to build this image with provenance and an SBOM, and I want to push this to Docker Hub. And you can see when you do this, there's this BuildKit scanner coming in. So this is being kind of added into BuildKit so that you get an SBOM created. And another thing you can see down here is instead of just pushing a single manifest for a single arch image, I'm actually pushing an attestation manifest and a manifest list. So all these artifacts as described earlier. All right, let's grab this tag here and make this a bit more visual. So this is a very simple application. Online service. If you want to ever introspect some metadata about Docker images, this is a great way of doing that. Looking at this is kind of what I described earlier. You have your OCI index now. This is the image that we've just built. And down here, we have the attestation image. I can now click in here, and I start drilling in, right? That's why this thing is really useful. You see two attestations. We've built an SBOM, and we built provenance attestation. If we drill into the provenance here for a second, you see an awful lot of information. But firstly, we see the subject. So we created a tag CD, and it was kind of for a particular platform. It was also for a particular digest. So this is what we are testing to. And then here's all the information that BuildKit has captured for us. So you can see the base image being added with tag and digest. So there is no guessing anymore. Am I using the correct version of a base image? Is this outdated? It's all captured right there. You get like the source maps. You get all the individual build steps, their input, their environments. In early versions of BuildKit, you would be seeing secrets here too, but they fixed that in the meantime. And if we go all the way, so these are all the build steps, and then we see labels. We see the materials going in. So we see which BuildKit scanner was being used, which version of BuildKit. So you start seeing how all the things that kind of go into your build are being documented. You can see how the build was being invoked, and then which layers were produced. You go all the way down. This area is really interesting. Have you ever tried to like reconstruct a Docker file from an image that you found somewhere? I've been doing this in the early days an awful lot. This is the Docker file that was being used, encoded as base 64 string data here. And this is done because there are like source maps for everything. So each layer of an image is now can be associated to particular instructions in your Docker file. And that's all encapsulated into the provenance attestation. I don't think there's, and down here we have kind of like the Git metadata, what was being built. So I did the build out of a Git repository, and that is the Git remote URL and the commit char. So let's go back a step and take a quick look at the SBOM. Again, subject and predicate. In this case, it's an SPDX document. Oops, sorry. And SPDX documents are structured in with 3 top-level elements. It's files, packages, and relationships between these 2 things. So firstly, we see all the files that are being identified. If I scroll for a very long time, you'll see packaged. Let me actually try to. Oops. So here we see kind of like the references, like which package references what file. And let me just find a package for you real quick. A lot of data. There we go. This is how packages are being represented. They have a name, some metadata, some external references. We have a Perl here, which is really important because that's what we use in Docker Scout to match it against CVEs. Again, some more metadata. And if you then establish the relationship to files, you can already immediately know where this package was being added into your container. So let me do this real quick by typing Docker Scout. Oops. I want to bring in this image real quick. And the thing that you can see here now is that we actually didn't have to pull down the image. We got all the information from these 2 attestations. And the thing that we can do now, we can tell you exactly what was the base image. Again, you saw that being captured in the provenance. We can give you exact locations of where's this image coming from, which Git repository. There's even a link here that will hopefully take you to GitHub. And very importantly, there are these lines here. So this libSSL, part of the OpenSSL package, in our particular case, is coming out of the base image. So it's coming out of layer 0, and this is exactly what this piece tells us here. So again, using the provenance attestation, we were able to match the information that a particular package via file relationships was added by a particular layer in your Docker file. And you can actually even read the text here. And of course, clicking this would take you straight to the line in GitHub. And we have other examples here. Like this is a little bit more, like including line breaks and everything. This is exactly how this looks in your Docker file. The next thing that I can show you is let me start. I created a simple vex statement. Again, the one from the slides, and I want to show you what happens when you start applying this. So there are various ways you can attach this to the image. You can store this in Scout. In this particular case, I just want to say vex location and pass the directory or file path to the vex locations in. And you can immediately see we effectively vexed out a vulnerability on Express. And in this case, I trust this. There are various other CLI options here where you can say, I don't trust Christian, I only trust this guy. So it's really up to you as a consumer to say, OK, I am going to trust this. But it is a great way to present additional information. If you attended the keynote earlier, we're using the same technology for conveying what packages are being used at runtime when you deploy images into production using Sysdig or potentially other integrations in the future. So these are the packages loaded that you should look at. Right. Now I want to show you real quick one of our so there is a sample repository on the OpenPubkey org, and I want to quickly show you what's changing if you look at one of those attestation images. So here, nothing is, like, it looks exactly the same. What's going to change is when you start drilling into, let's click into the provenance. And here, instead of seeing an in toto statement with a subject and the predicate, you get the payload. And this is, again, the statement. And you get the signature down here. And then it's just a simple matter of running a new plugin that we just released into the OpenPubkey organization that you can start using today and like explore the possibilities, right? You can see we're expecting 2 attestations. Both of those attestations are verified for certain criteria. So, for example, are we referring to the correct tag? So has no one tampered with? Is it signed by? Is the OIDC token signed by the correct authority? Is it kind of the correct GitHub action run? And does the repository owner actually match? In this case, it's OpenPubkey, not Docker. And the same down here for the provenance attestation, with the added assertion around like the git commit SHA. Just want to show you one last thing. There's a demo repository here. So if you're building images on GitHub, here's a quick demo on how you can set up your build to start signing these images using that technology. So if you're familiar with the Docker build and push action, this actually has not changed at all. So there's no configuration needed for this particular piece. The only manual thing right now for this very moment are these 3 driver ops that you need to add. Although we're going to be changing that in the future by getting this into BuildX. So really starting to embed this in the tool. You need to effectively use a different BuildKit image and just passing in some environment variables that GitHub already provides. Using that, you're able to then start signing your images and start exploring the new signing technology. With that, let me just quickly check the clock. We have about 10 minutes to go. Do you have any questions for me today? I think you need to. Oh.
Yeah, if you don't mind coming up to the mic.
Okay.
This is funny.
So just a quick scenario to sort of verify that I understand. So say you have a website that's built on Django, and you have a container locally, and you do a build of that container, or you do a build of that image, and you push it up to Artifactory. How do you tell it that you want that to be pushed up with an SBOM so that a coworker can then pull that down from Artifactory and know that everything's good?
Right. So the command that I run in the like this. Sorry. This command works. Sorry. This. That's not. You can't read that. Let me go back to the slides. This command works exactly the same if you were to push this onto Artifactory. Like that does not change at all. If you replace the tag down here with your reference to Artifactory, you would effectively be starting to build images with provenance and SBOMs and send them off to Artifactory. Yes, yeah. Yeah, that's all, that's literally all you need to do.
Thank you.
You're welcome.
Any more questions?
When you added the signing in, you ended up with this base 64 encoded provenance, for example. How do you recover the provenance back from that? Because it didn't appear to be long enough to encompass the whole provenance.
Right. It is actually the full payload. There is no magic going on. Let's go in and where would that be? It is actually pretty long. Ugh. There. Any other questions?
Okay. So I think that's it.
Thank you.
If you have any more questions, you're welcome to come in after our session and speak to Christian directly. Thank you. Have a wonderful day.
Thank you very much. Thank you.